YouTube. So Margaret, just let me know when I'm live on there and I'll get started. Okay. Hi, I'm JJ. I'm here today to talk about plotting in deephaven. I'm a developer relations engineer with deephaven, and I'm a Python enthusiast and someone who enjoys data science and plotting. So I'm excited to talk about some of the things that you can do with deephaven's built-in Python plotting API. I had originally intended to talk about matplotlib as well, but I decided I want to keep that in its own learning session. So keep an eye out in a week or two for another learning session talking about matplotlib and deephaven, and specifically real-time matplotlib stuff. So without further ado, let's just go ahead and jump right into it. So the first thing that we want to answer is that who cares about plotting? And before I get into any of these points, the short answer is everyone cares about plotting, because unlike a good book that paints a picture for you when data is just flying across the screen, the data is flying across the screen, you can't really make much out of it unless you you paint a picture to go along with it. But specifically, plotting is incredibly helpful when you are presenting anything to non-technical audiences specifically. However, technical audiences also care about it because, once again, even as a data scientist myself, if I see a deephaven table, for instance, or a pandas data frame with data, numbers flying across the screen, I don't really know what to make of it unless you actually show me a picture to go along. In the agenda today, I just want to talk a little bit about plotting in Python. I'm going to follow it up with some syntax and examples of deephaven.plot, and then I will last show an example of real-time plotting. And I won't talk much about real-time plotting because the cool thing is you don't actually have to do anything different with deephaven's Python plotting API to make it work in real time. The workflow is identical for static and real-time data. So plotting in Python, it's been around for a while, and the most popular plotting library, which actually has syntax fairly similar to deephaven's plotting API, is matplotlib, which was built based off of MATLAB's plotting functionality. And as someone who has used MATLAB a lot in the past, I could see why they used MATLAB's plotting functionality. It was pretty easy to use. It was a bit slow. But the syntax was human legible and it was easy to customize. And so deephaven's plotting API has taken a lot of those concepts and extended those towards real-time data. And so that's really cool because it makes plotting anything very easy and straightforward. And as we'll see in a little bit, the syntax for plotting different kinds of things, whether it's static or real-time, is basically identical. So deephaven.plot, well, deephaven specifically was built for financial applications. However, its use cases expand far and wide. And so you'll probably see in some of the plot examples that I'll show that they would be quite suitable for a financial application such as stock trading or crypto investing or stuff like that. Deephaven in and of itself is built to support real-time data. And so as an extension of that, deephaven's plotting API gets to take advantage of all the cool tricks that deephaven has up its sleeve to make working with that real-time data easy than you thought it would be. And then lastly is that deephaven's plotting has built-in smart downsampling. So if you're ever working with particularly large data, maybe you've got a table with millions or billions of rows in it, and you want to plot all of that stuff, the smart downsampling will make sure that you don't your computer doesn't get bogged down trying to plot billions and billions of data points. I've actually encountered that issue specifically with matplotlib. I tried to plot millions of data points, and it actually locked up my computer for a little while until the picture showed up. And then when I was trying to pan around and look at different stuff, it just took forever. So it's pretty cool. So I first want to talk about syntax. So there's some text on the screen. There's also an example of a tree map plot at the bottom. Tree maps are the most recent addition to deephaven's built-in Python plotting API, and I will show an example of making one, but they look really cool, and they're informative, and it's actually really easy to do. So the first 3 lines that I have on this particular on this particular slide, show an example of a typical workflow when using deephaven's plotting. You'll always be importing the same thing. It's a single import statement. It's from deephaven.plot.figure, import figure, and that second figure there has a capital F. You'll then instantiate an instance of the figure class, and then you'll call whatever plot methods and options and so on and so forth you want. And then the last thing you'll do is call .show, and it'll bring that plot into the console. In this case, plot method is the method to create a particular type of plot, whether that's plot XY for a line plot, XY hist for a histogram. There's category plots, pie plots. As you see at the bottom here, there's tree map plots. And then some of the plot options that you can give it are methods for formatting, things like twin X and twin Y, which will make multiple plots share an axis. Other things like you can change the way a plot shows up in your console, like for instance a stacked area chart. You can make sure that the area under a curve is shaded, or you can have histograms or category histograms, the bars stack one on top of another, and so on and so forth. And I'll show those in a little bit. So generally speaking, no matter what plotting method you're going to use, whether it's you want to plot a line or a bar plot or a pie plot, etc., you're going to give it the plot method, the same input arguments. Two that never change are the series name, which is the name you're going to want for your plot. In this case, in the figure at the bottom of the screen, because there's only actually one thing being plot, it doesn't actually display the series name. However, if I displayed a second OHLC plot, you would actually see the series names on the right-hand side, and it would be immediately obvious which is which. The second thing you're going to do is supply the table, or give it the name of the table from which you source your data. Because we're using deephaven's Python plotting API, it is built to be used on deephaven tables. And then the last thing you're going to do is give it the data that the plotting method needs. So in the case of an XY series plot, you're going to give it two column names. The first column name, it corresponds to the data that you want to be your X variable, and then the other is your Y variable. So here's an absolute basic example of what plotting in deephaven can do. And so in just a few lines of code, you can create a sign plot. I create a table with 100 rows in this case. There's two columns, one called X, one called Y. Y contains the sign of the X column. I then, once again, you can see I'm creating an instance of the figure class. And then on that instance, I call plot XY and show. And so this is a simple example, and it's actually going to be the first example I show in the IDE itself. And so this is the last slide I have. And because I think plotting is best shown through actual running of code, I'm going to now go over to my deephaven instance where I have a few different scripts up and running, or not up and running yet, but a few different scripts that I will run. And typically I would show my face in the corner of the screen. However, because we're actually going to be looking at plots, I don't want my face getting in the way of any of the cool looking stuff that's going to show up. Anyway, so this first example, as you just saw, I just showed this code here on the left, and so this is the same exact code here, and I'm going to run it. And so just as a notice, some of this code is going to run particularly slow. It's because I'm streaming not only via OBS to stream on YouTube Live, but also I'm streaming to a Google Meet as well. So that does take up quite a bit of my processor's computing power, and these things are going to run a lot slower than you would see in a standard console session. But basically what I do here is I create an empty table, fill it with data, and then plot it. And so this is the standard usage pattern in any case, regardless of the type of data you're working with. But as we'll see in the next few examples, you can specify some options and different plot types to make the plots look a little bit prettier, or show different types of data and whatnot. And so once again, we see the exact same figure that we saw on the last slide. It looks identical, so surprise, surprise. The next thing I want to show is two different plots, and in this case I'm going to be plotting some actual data, not just a sine wave that I made myself. I'm going to be plotting some data from a 100-kilometer bike ride, and this data was recorded with a few different instruments, either on the bike or a fitness watch or stuff like that. So I'm actually going to read the data from a CSV located at a URL, and then I'm going to create two plots. The first uses the same workflow that we saw in this first example, where I simply call the plotting method and then call show. The one thing that I want to show here is that when you source your data from a table T, you can actually apply table operations to that table in your plot method call. So in this case, I want to plot data from the source table only where the speed is greater than 0. It's perfectly valid to do this. You don't have to apply this where filter or any other table operation outside of the plotting method. You can do it from it. And then the second thing I want to show is as I mentioned, there are plot options that you can specify. In this case, so the first one I want to show is plot distance. This is what I just went over. We can see the distance increasing over time. And then the second thing that I plot is actually two different XY series on the same plot, and they share an x-axis. And so that x-axis being shared is specified by this x-twin call. And so that means there's going to be two separate y-axes. The axis on the left, so this y-axis on the left here, is always going to correspond to the first thing that you plot. So in this case, it's my altitude. See, the altitude actually goes below sea level, which is kind of interesting. And then what appears on the right is always going to be your the second thing you plot. And so in this case, I plot the speed, and the speed should never drop below 0, because we're talking about, you're either moving or you're not. And so it's, as you can see here, it's very simple to plot multiple series on the same plot. And if I didn't want them to share an x-axis, I wouldn't specify this x-twin call. However, because these are both using the same time column as the x-axis here, I want them to share it. So I specify that. As I mentioned, there's a few different, actually not just a few, there's quite a few different plot options that you can specify. In this case, I want to specify a stacked bar plot. Or really, in the case of plotting an XY series, I want to shade in the area under the plot so that I can see, it provides a much better visualization of just how large the data is. And so in this case, by specifying, by saying axes here and calling it a stacked bar plot, it actually shades in the area below the XY series, and we can see here that it's working as intended. And so the same principle applies from the previous script. If I wanted to plot a second thing and I wanted them to share an x-axis or a y-axis, for instance, all I'd have to do is call the appropriate method, whether it's x-twin or y-twin, and then make a second plot. And it would plot another stacked bar with a different color, and you can click in and out. So up next, I want to show another example of plotting an XY series, but in this case, we're going to show plotting as a scatter plot. And so in this case, what I've got is, I don't know what I've got here is I'm going to actually plot the speed and the distance on the same plot as opposed to altitude and speed. And so I want both of them to be scatter plots. So instead of plotting lines, I want individual data points on top of each other. And because they both use the same x data, I'm going to call x-twin. And so for each one of these things, I make sure to specify that it's doing a scatter plot style. If I were to remove one of these, one of them would be a line and the other would be a scatter plot. And when I run this, you can see plot XY scatter appears on the screen, and I've got two different scatter plots. If I want to zoom in and take a look at this big spike here, we can see that this bike rider had a huge speed burst here right around 12:23 p.m., going over 62 miles an hour, or kilometers an hour, sorry. That's pretty fast for being on a bike. Pretty impressive. But yeah, so we can see here that it's simple, and the workflow is very, very similar to specify different plot styles, whether you want a stacked bar, whether you want a scatter plot, or anything else. So I did talk about stacked bar, and as we saw, when you plot with the stacked bar style with an XY series, it shows up as with the area under the curve being shaded. There we go. Where it's shaded in. However, if I do the same thing but with a different type of plot, so for instance, in this case, I want to do a category histogram. So I'm going to create two tables. Each has 3 categories. There's A, B, and C, and each has a number for each category. I'm going to create 2 different plots to show you what it looks with and without the stacked area. So if you don't specify stacked area type, they will actually show up side by side, the category histograms. So because we're plotting from 2 different tables, we've got the categories sitting right next to each other. But when we specify the stack bar, it's actually going to put those two things one on top of another. And once again, you can click in and out of each one, and it's going to scale the axes appropriately and do all the heavy lifting for it. Again, there are different types of plots, and I'm not going to go into every single one here, but I think another one that's really useful is histograms. And in the case of histograms, you actually only need to specify a single column of data, and because what a histogram does is it counts the number of occurrences of unique values in a particular column. So in this case, I'm going to create a column called values. I'm going to fill it with some data, and it's going to count the occurrences of each one. The other thing I specify with a histogram is the number of bins by the nbins argument. And because we've got 5 unique values here, I'm going to specify 5 bins. Oh, I don't know. Keyboard's been acting up today. But when I run this, we'll see here that the histogram will pop up in the bottom right corner as soon as it's done. And it's going to count the number of unique values in the values column. And with 5 bins, having 5 values, you're going to see them show up accordingly. So I mentioned previously that tree maps are the latest addition to deephaven's plotting API, and I just want to show how easy they are to use. So I'm going to once again read data from a CSV. In this case, I will explore what this looks like before actually running the code to create the tree map plot. But what we've got is a table that gives some information on different market cap, or a market cap for different companies that are parts of different industries. You can see labels here. Companies IT, AMD, they make computer chips, and it gives a value. But you also need to supply, the table where the data comes from, an ID, which in this case is going to be our label column, and then a parent column, which is appropriately named parent. When I run this single line of code, we're going to see the same histogram that pop up in the bottom right that we saw previously. And what's really cool is that these are completely interactive. So if I want to go take a look at, I don't know, E, I can come back here. I can also click, just go back to the financials part of the tree map, and then I can. And so these, just like any other plotting method, work in real time all the same. And so I've been talking a lot about that, but I haven't shown any examples. So for my last example for this talk, I just want to show an example of real-time plotting and how the syntax is completely identical to everything we've seen so far. So in this case, I'm going to do, once again, the bike ride table. I'm going to read the same bike ride data that we read previously. And I'm actually going to replay it with a table replayer. And so doing that is pretty straightforward, but I'm not going to concern myself too much with that. What I am going to show here is my plotting method. And hopefully you'll be able to see that the plotting method, the code that I use is completely identical with only one change. So if I take a look here, plot bike metrics, we can look at the bottom, and so I've got the same table name, same plot name, plot altitude speed twin x. I call plot xy with x twin, another call to plot xy and show. And then when I come over here, this is identical, with the only difference being that I specify my table that contains the data to be the real-time table. And so with all the code the same, but just sourcing my data from a real-time table as opposed to a static table, I'll run this code, and we'll see that the table is going to start updating in real time with rows coming in, and I had to do absolutely no extra work, and the plotting is going to not only plot the real-time data, but it's going to scale the axes appropriately. Accordingly, I can still zoom and do everything else that I want. I can look at little windows as if they were static. And yeah, all the functionality is all the same. So I like to keep these talks fairly short, usually around 20 minutes or so, and I believe we're right around the 20-minute mark. So that's the last example I have, and I'm going to open it up to questions now. As I mentioned before, I'm presenting not only to you guys here on YouTube, but also to a Google Meet. You guys are not able to hear the questions that come through Google, so if I do get any questions there, I'll make sure to repeat them before I answer. So I'll open it up now. And yeah, anybody have any questions? Well, there's no questions in Google, and I don't see any in the comments. So this talk will be available after the fact. So if you do come across this video and you have any questions for us, please leave a comment below, and we will answer it as fast as we can. And yeah, keep an eye out for a future talk on specifically using matplotlib and deephaven and doing some real-time matplotlib stuff. Thanks.